Hello student, welcome back to our M.Sc First Physics Semester 2nd course, that is Atoms and Molecules, and our this is 14th lecture. And in previous lecture we have discussed about the IR spectrophotometer, or simply we call it as a instrumentation of the IR spectroscopy, and in that we have covered the basic principle of the IR spectrophotometer and the different parts of the IR spectrophotometer, like a radiation source, the four optics arrangement, sample cells and sampling of substances, also the monochromators, detectors, recorder. These all are the different parts of the, or the main parts of the IR spectrophotometer. With the help of we get the IR spectra, and we have discussed in detail about each and every part of this spectrometer, and also we have discussed about the schematic representation of the IR spectrophotometer and how it works, and from that how we get the IR spectrophotometer, sorry, IR spectra, and how we can study the physical as well as the chemical property of that particular sample with the help of IR spectra. So all those things we have covered in our previous lecture. Now in this lecture we have to study the different sample handling techniques in the IR spectroscopy. That means in IR spectroscopy we cannot use the sample as it is, but there are some different sample handling techniques so that we get the proper spectra. As already we mentioned in our previous video, solid, liquid and gas have different sample handling techniques. So here we discuss in detail. IR spectrum of compound can be recorded in many different forms, such as a liquid, solid, gas and solution. That means the sample which is in the form of like a liquid, solid, gas or solution, it may be one of them. Some of the material are opaque to the infrared radiation, so in order to obtain the spectra they must be dissolved and diluted in a transparent matrix. That means if we consider a particular materials, they are opaque to the infrared radiation, and so that in order to obtain the spectra of that opaque material to the infrared radiation, it must be dissolved or diluted in a transparent matrix. Then and then we will get the proper spectra of that sample. For recording IR spectra, the sample should be properly dry, as water absorbs nearly 3710 and 1630 centimeter inverse. That means this is the range for the absorption of the water. That means if we record the IR spectra, sample must be dried. If it consists of some amount of water, then water absorbs the nearly about these radiations, and this is not beneficial to get the proper spectra of that sample. The sample should be perfectly dried, since cell materials like sodium chloride, potassium bromide are usually spoiled by the moisture. That means due to moisture our spectra is not proper, or the obtained spectra is not in proper manner. So in order to that we have to dry that sample in a perfect way, since cell materials like a sodium chloride and potassium bromide are usually spoiled by the moisture. That means the cell material, that means the sample in which the sample cells in which we place the sample, and this sample cell made up from the sodium chloride or the potassium bromide, and due to the presence of water these material get spoiled and we get the unaccepted spectra. That means the spectra is not proper, but if we have to obtain the proper spectra we have to use different techniques. Recording of IR spectra of solid sample are more difficult because the particles reflect and scatter the incident radiation, and therefore the transmittance is always low. Three different techniques are employed commonly in recording the spectra. That means the problematic condition is in the solid is more, because in a solid the particles reflect or scatter the incident IR radiation, and due to that we get the low transmittance and we are not able to obtain the proper spectra. So there are different techniques to employ the or to handle the solid material in order to record the spectra. So all those techniques are, that is as a pressed disc, second one is the Azimul R Paste, and third one is the as a film. So all those three techniques which is used in a solid to get the proper spectra. So first we consider the case of the solid samples. So solid samples, there are several methods by which an IR spectrum of a solid sample can be recorded. First method is the as a pressed disc. The first common method involves the mixing of finely ground solid sample with a powdered potassium chloride. That means if we take a sample and we mix this finely ground solid sample with the powdered potassium chloride, that means there is a mixture of these two quantities, that is a solid sample and which is the finely ground and the powder of potassium chloride. A translucent pellet of this powder mixture is formed by pressing it in a mechanical pressure. That means this mixture form like a translucent pellet of this mixture and which is formed with the help of by giving a mechanical pressure. The main advantage of using KBR is that it does not interfere with the bands due to compound, since KBR is transparent to IR radiation and thus gives a better spectra. That means what is the purpose of the KBR? Why we use the KBR? Because the KBR does not interfere with the bands due to compound, since KBR is transparent to the IR radiation and we get the proper spectra of the given sample. The main disadvantage of this method is that KBR absorbs water quickly, which may interfere with the spectra that is obtained. That means the KBR has a property to absorb the water quickly, but if we have the water in recording the sample, then our spectra get disturbed and we are not able to obtain the proper spectra. So this is the disadvantage by using the KBR. Now the second technique is the Azimul R Paste. In this method, the slurry or mole of the substance is prepared by grinding it into a fine powder and dispersing it in a molding agent such as a paraffin oil, we call it as also nuzol, and hexachlorobutadiene, and the perfluorokerosene, we also call it as a fluoroloop. It is smeared between two cell windows which are then held together. That means in this method the sample slurry or mole of the substance is prepared by grinding it and this is into fine powder. This is converted into fine powder and this powder is dispersing into or in the mulling agent. The mulling agent used as like a paraffin oil or nuzol or the hexachlorobutadiene, or also we can use fluoroloop. So all those are the mulling agent. They mix or we mix this aging mulling agent with the fine grinded solid substance and then it smear between the two cells windows which are held together. In this way here we prepare the sample for the recording of the spectra. The mule spreads out as a very thin film and window setup is placed in the path of the IR beam. That means in this way we are able to obtain the very thin film. That means if we grind the sample in a powder form and this powder is dispersed on the mulling agent or in the mulling agent like a paraffin oil or fluoroloop or hexachlorobutadiene, and again this is smeared between the two cell windows and in this way we form the thin films and again window setup is placed in the beam of the IR radiation, so we get the proper spectra. The main disadvantage of this technique is the interference due to the absorption bands of the mulling agent. That means due to mulling agent we get the some another bands which are unwanted bands. That means our spectra get disturbed due to using of the mulling agent, and we are not able to get the proper spectra of that particular sample. So this is the disadvantage of this technique. The absorption bands of usual are found at 719 centimeter inverse, 1376 centimeter inverse, 1462 centimeter inverse, and 2915 centimeter inverse, which interfere with the certain important group frequency. That means we get the unwanted bands due to the using of the usual mulling agent, and these bands found at this range, and in order to get the proper spectra, this is actually the unwanted bands. So here is the disadvantage of the using mulling agent like a nuzol or paraffin oil. For the best result, the size of the sample particle must be less than that of the wavelength of the radiation used. That means in order to get the better spectra, the condition is that if we incident the IR radiation, then we have the particular wavelength of that IR radiation, and if this wavelength must be, or this wavelength is equal to the sample size of the sample particles, then we get the proper spectra. So this is the proper condition to get the proper IR spectra. Now the next technique is the as a film. The third method is dissolve the solid sample in a suitable non-hygroscopic solvent, usually methylene chloride or carbon tetrachloride. That means in this technique we use the solid sample in a suitable non-hygroscopic solvent. That means we dissolve this sample in a suitable solvent like a solvent methylene chloride or carbon tetrachloride. These two solvents are generally used for the dissolution of the solid sample. A drop of this solution is deposited on the surface of the potassium bromide or sodium chloride plate. That means this mixture or the drop of this mixture, that means the solution of the methylene chloride or the carbon tetrachloride with the solid sample, and the drop of this solution is deposited on the surface of the potassium bromide plate or sodium chloride plate. So the solution is then evaporated to dryness, and the film thus formed on the KBR disc is analyzed directly to obtain the IR spectrum. That means first we mix the or we dissolve the solid sample with the suitable hygroscopic solvent, like suppose we take methylene chloride, and the drop of this solution is deposited on the surface of the potassium bromide plate, and after that by the process of evaporation this is exposed to the dry, and after that the film is formed on the KBR disc, and then the film is ready to expose the IR radiation, and we get the spectra of that particular sample. So this is the another method to get the proper spectra of the IR spectroscopy. The most important thing is that the film should not be too thick, otherwise light cannot pass through it. That means the thickness of the film is in a small size, or which is not too much thick, so that the IR radiation easily pass through it. So if we have the more thickness, then the IR radiation cannot be detected or cannot be passed through that sample, and we are not able to get the spectra. This method gives good result with a dilute solution of the compound in a non-polar solvent. That means this result gives us better result when we use the solvent like a non-polar solvent. So all those three techniques are used to prepare the solid sample in order to obtain the proper IR spectra. Now the second is the liquid samples. Liquids are studied neat or in a solution. A drop of neat liquid sample or a solution of the sample in appropriate solvent is placed between the two plates of the salt, that is a sodium chloride or potassium bromide, to give a thin film and analyze to obtain the spectrum. That means in a liquid samples, here we place the drop of given sample or the neat liquid sample in between the two plates of the salt. The salt are generally used as that is a sodium chloride or potassium bromide. That means if we place first plate and in between first plate, and after that we drop a liquid sample, and after that again we place the another plate. That means the liquid is sandwiched between the two salt plates, that is to give the thin film. That means there is a formation of the thin film, and in this way we analyze the spectrum of the given sample. The plates are transparent to the infrared light and do not introduce any lines onto the spectra. That means the salt plate like sodium chloride plate and potassium bromide plate, these all are the transparent to the IR radiation, and so they do not introduce any spectra or any band onto the our sample spectra. So this is the beneficial to get the proper spectra of given sample. Salt plates break easily and water soluble, therefore compound analyzed by the method of should be free from the water. That means there is no problem of the moisture, so here we get the proper spectra by using this method, because the salt plates easily breaks and water soluble, therefore the compounds analyzed this method should be free from the water. So here we get the pure spectra of the given sample. Here is no band presence due to the moisture or any water content. Spectrum obtained by this method is known as a neat spectrum, since no solvent is used in recording the spectrum. That means in this method we are not using any solvent, like before we mentioned the solvent like methylene chloride, carbon tetrachloride, or the another mulling agent like nuzole, hexachlorobutadiene, all those things here we are not using. Here we just use only the two plates of the salt. So this is the very beneficial method in order to get the proper spectra of the IR spectroscopy or given sample. Now the third sample is the gaseous sample. The gas is introduced into the special cell with a long path length, and walls of it both end are normally made up of NaCl. That means for the gas, we know that in the gas the particles intermolecular distance is large, hence for the gas samples we require a long path length, and therefore the gas introduced in a special cells which having the long path length, and the walls of it both at the both ends normally made up from the NaCl. That means if we take this special cell and having its path length is large and its end are made up from generally the sodium chloride. Gases having very less density compared to the liquids, and hence path lengths should be correspondingly greater, usually 10 cm or longer. As already mentioned, in a gases we have less density, that means the inter particle distance is very large, or the particles move here and there, and this is comparison with the liquid. That means the density is less as compared to the liquid, and hence we have the long path length special cell having length 10 cm or more than that. The vapor phase technique is limited because most of the organic compounds have low vapor pressure to produce the useful absorption spectrum. That means there is a vapor phase techniques, but for the vapor phase technique the limitation is that the organic compound have too low vapor pressure. So here we are not able to obtain the proper spectra with the help of vapor phase techniques due to this limitation. So the absorption spectrum is not good by using this vapor phase techniques. So we can avoid this vapor phase technique. So in this way we get the spectra of the solid sample, liquid sample, and gaseous sample with the help of IR spectrophotometer. That means there are some problematic condition when we use the sample as it is, or we are not able to get the proper spectra, then we get the or we use the different techniques like we studied before. So we get the proper spectra of the IR spectra or IR spectroscopy or given sample. So in this way we use the different sample handling techniques for the IR spectroscopy to get the proper spectrum. Now there are different application of the IR spectroscopy. So let's see the applications of the IR spectroscopy. It has been great significance to scientific researchers in many fields, such as first is the IR spectroscopy is used for the protein characterization. Second one is the nanoscale semiconductor analysis. That means if we have to analyze the semiconductor material but which is in a nano size, then we use the IR spectroscopy. Again, space exploration. That means if we have to explore something in a space, then we can use the IR spectroscopy. Now fourth one is the analysis of gaseous, liquid and solid samples. That means, as already mentioned in this lecture, there are different techniques to get the or to obtain the spectra of gaseous sample, liquid sample and solid samples. So with the help of these techniques we get the proper spectra and we analyze that gaseous, liquid or solid sample. Now the fifth application is the identification of compounds. Suppose we have some unknown compound and we have to identify that compound, then we can use the IR spectroscopy. So the identification of compounds is done with the help of the IR spectroscopy. Next application is the quantitative analysis. That means if we want to study the or quantitative analyze the given sample, then we can use also the IR spectroscopy. Next application is that information regarding functional groups of molecules and constitution of molecules can be deduced from the IR spectrum. That means if we place the sample in a IR spectrophotometer, then we get the IR spectrum, and from that IR spectrum we get the information about the functional group of that molecules and constitution of the molecule. So in this way the IR spectroscopy help us to know the functional groups of that molecule and constitution of the molecules. So this is the very best application for the chemistry field. Eighth one application is the to know about the interaction among molecules. That means we can study the interaction among molecules with the help of IR spectroscopy. So in this way the IR spectroscopy used in a wide range, or it has a wide applications. So it helps us to study the different phenomena in different fields. So in this way we have covered the different sample handling techniques in the IR spectroscopy and the IR applications of the IR spectroscopy. So in this way we have covered all the topics of the IR spectroscopy. Now in our upcoming video we will discuss about the new technique, that means the techniques which is in a module 3rd. That means we have covered the microwave spectroscopy, that is the rotational spectroscopy, and second one is the infrared spectroscopy. The infrared spectroscopy is also known as the vibro-rotational spectroscopy. So all those things we have covered up to this, but in our upcoming videos or in next video we will discuss about the some different technique, that is a spectroscopic technique.